Welcome to 4.1 congruence. So first off, congruent just means same size and shape. So on the left here, we have congruent trapezoids. They're all trapezoids, and they have the same size, lengths, and angle measurements. On the right here, we have triangles, but notice the one on the right is an obtuse triangle, with the two on the left are acute, and none of them have the same size, angle measurements, or sides together. So next, incongruent figures. All parts of one figure are congruent to the corresponding parts of the other figure, right? The parts that are in the same position. Incongruent polygons, that means that the corresponding sides and corresponding angles are congruent. So here are corresponding angles in our picture. Angle A corresponds to angle F, and they're congruent. B and E, and angle C and angle D are congruent. Those are our corresponding angles. And our corresponding sides, that would be AB and EF, or FE, BC and ED, and then AC and FD. Finally, to write a congruent statement, what you do is you follow the same pattern when naming your triangle. So if I name it triangle ABC, I'm going to follow the same pattern on the other triangle, triangle FED, and we would just say that they're congruent. Doesn't matter what order you go in, such as triangle BCA, right? I went from the 2 to the 3 to the 1. Just follow the same pattern, so EDF. In our example here, we start with the triangle congruent statement, which in this case it's triangle JKL is congruent to triangle TSR. What I want you to be very aware of in this question is that the picture does not matter in the slightest. Once we have the triangle congruent statement, we can go ahead and separate our congruent angles and our congruent sides. We're talking about the corresponding letters that will give us the angles. Angle J and angle T, those are the first letters, so those are congruent. Angle K and angle S, angle L and angle R. It's all about that congruent statement and where they line up. To find the congruent sides, you just take the first two letters, JK and TS, then the second two letters, KL and SR, and then the first and the last, JL and TR, and those are congruent. Just make sure you follow the same pattern. So if you go 1, 2, then you go 1, 2 for the other one. Our next example here, we're using congruent parts in order to solve for x and solve for y. We first look at where the x value is, and we have 2x minus 4 on QR. We look at our congruent statement. QR is the last two letters, and the other figure, the last two letters, is FG. So QR is congruent to FG. Because they're congruent by definition of congruence, we can say that their measures are equal, their lengths are equal. And now we can substitute in 2x minus 4 equals 12. Then we can add 4 over and get 16, and divide by 2 we find that x is 8. To find y, we're going to do something similar. This time y is in angle Q. Angle Q is the third letter, which corresponds to angle F, which is the third letter in the first trapezoid. So we know that angle F, which is 68, equals r 6y plus x. Right? Angle F is congruent to angle Q. By definition of congruence, their measures are equal, and we can substitute in again. This time we know what x is, so we can substitute 8 in for x. Subtract 8, we get 60. Divide by 6, we get 10. Our next theorem is the third angles theorem. The idea here is if you have two congruent angles in a triangle, then the third angles are automatically congruent. You could find how big angle C is and how big angle F is first, set them equal, then find out they're congruent, but instead we would just use this theorem to go one step instead of 5. So again, if two pairs of congruent angles are in a triangle, then the third pair is automatically congruent. So to use this theorem here, we're trying to find angle BDC. Well, we know that angle BDC is congruent to angle ACD, because the third angle theorem. The idea is angle A is congruent to angle B, and angle BCD is congruent to ADC. So therefore, by the third angle theorem, we know their measurements of ACD and BDC are congruent. Their measures are equal. So to find this, we have 45 degrees, we have 30 degrees. If we subtract that from 180, we find that the angle is 105. Since ACD is 105, that means that BDC is 105. Our final theorem, these are actually, we've seen these before in Unit 2. The idea of reflexive just means that it's congruent to itself. Typically we use this with overlapping triangles. The symmetric property just means that A equals B, then B equals A, right? We can flip around our letters and it won't change which side the equal sign is on. It won't change the outcome. We use this typically in proofs when we get our statement backwards. And then finally, the transitive property of congruent triangles, right? A equals B, B equals C, therefore A equals C. And again, here we're going to use this in proofs typically. All right, good luck with the practice and application. See you on the lesson check.